Okay, so we want to look at 2.7, number 7b, which says true or false, AB symmetric implies A times B symmetric. Right, so if you have two symmetric matrices and you multiply them together, you get a symmetric matrix. That seems legit, right? So just like, first blow, maybe, probably? I don't know, feels true-ish. So, what does symmetric mean? First
If you
first.
transpose it, you get itself.
Okay, so this statement, A and B being symmetric, I can write down that I know that A transpose is A and B transpose is B. Like, so I'm just kind of thinking my way through this. Again, I'm wondering about AB transpose, right? Why am I wondering about AB transpose?
Because if it's equal to itself, if it's equal to AB, then it's symmetric.
Yeah, this is kind of the question that I'm asking, right? Like,
Yeah.
are these the same? Well, I don't freaking know. Let me play with it a little bit. This is still in the like sketchwork stage, right? Like, I'm not trying to write a proof. I'm just like playing with symbols, just to like get a feel. Okay, so AB transpose is. What do you transpose a product?
B transpose A transpose.
B transpose A transpose. Okay, and I know that B transpose is B and A transpose is A. So I know this thing is BA,
That's super not AB.
Yeah.
which is generally not AB. But maybe there's some weird shit where symmetric matrices always like commute with each other, right? Like, that's probably not true. I feel like they would have mentioned that to me. But like, maybe this is the homework problem where I'm supposed to figure that shit out. I don't know. Well, I guess what I'm going to do is try to find a pair of symmetric matrices that don't commute, right? Okay, how am I going to do that?
Well, you could just use trial and error.
Yeah, sure, okay. I'm just going to like try some shit, because worst case, I can't figure it out, and then I can maybe try to use what I learned to build a proof. What's your favorite symmetric matrix?
Two. Something else.
Twos, top and bottom?
Yeah. Some other shit in the other dag.
I think 1 and 0.
Okay, 1 and 0.
Okay. I was kind of hoping that you would tell me your favorite symmetric matrix was either the identity matrix or the zero matrix. Those are both good options to have, but neither of those options is a good candidate for something that won't commute, right?
Exactly.
So, good on you for avoiding it. Bad on you for not. Alright, so there's a symmetric matrix, right? I'm going to call that one A, I guess. I'm just kind of playing with stuff, right?
Yeah.
So what do I let? Well, what do you let B be?
All 1s.
Oh yeah, totally.
Okay.
I'm just done.
Okay. What do you get when you multiply these? So here, let's go like this. You guys do AB. You guys do BA.
Okay.
Okay.
Quick. Okay, so you guys should now have A, B, and BA.
Yes.
And we discovered that this is identically what Orion used on the homework. Alright, so what's A times B?
That is 3, 3, 2, 2.
Yep.
3, 3, 2, 2. And B times A?
3, 2, 3, 2.
3, 2, 3, 2. Oh. Huh.
Would you look at
Well, there's.
neither of them are symmetric.
Yeah, they're not symmetric.
But they can't.
And they're not equal to each other.
They are transposes of each other. Why is that not a surprise?
Because because of that.
Because B transpose A transpose equals
Yeah. Because, like, this, basically, right? Okay, so they don't commute, and so they are not symmetrical. Great. Cool. Check. Done. What would I have... Had these two been the same, what would my next step have been?
They come up with a proof.
I mean, I might try to come up with a proof, or I might try a different example, right? In the case that you picked, like, A or B was I or 0, if you find yourself, like, trying to supply a pair of matrices that don't commute, and you're, like, using zeros or identities or things with lots of zeros and ones in them, you should be leery of those examples, because lots of stuff is true for, like, permutation matrices or projection matrices that isn't true in general. Does that make sense? So there's some, like, stay away from the ones full of zeros and ones if you're looking for, like, typical behavior.
I just do like entries with decimals, like 1.7 or some shit, because like, there's no way I can fuck that up.
Yeah, that's fair. I feel like, yeah, this is one of the kind of things about, like, producing a random matrix is, like, human beings are not random number generators. You're bad at it.
Yeah, you said that like 2 weeks ago, and ever since then I've been doing decimals.
Yeah, that's really not a bad idea. I'm not going to do that up here because it's gross, but it's really a good idea.
It's really funny because for the same exact reason I started doing decimals, like when you said the 2 thing, that 2 times 2 plus 2, 2 squared.
Oh yeah, stay the hell away from 2s.
I'm using 2.5
Hey.
now.
You learned something really cool about that. You were there yesterday. You can't laugh.
Sorry, guys.
Okay.